So the question that we're going to look at today is constructing a binary tree from Inorder and Postorder traversal. The concepts that we're going to talk today can be used for forming a binary tree using a Inorder traversal that's given to you and a Postorder traversal. So basically, if you look at the question, you will be given two arrays of Inorder traversal and Postorder traversal, and it's pretty obvious that we have to form a tree and we have to return the main root node for it. So let's get into some description for this. Let's discuss more and then we can start with the coding. So if this is the post and the Inorder that we've been given, and this is the tree that we're looking at, we have to form this tree, right? So what are the observations that we can make by looking at the Postorder and the Inorder? First thing that we know for sure is that the last element that comes in the Postorder has to form the main root. We know that for sure. Now, if this is indexed, if we index the elements, if we look at the indexes of these elements in the Inorder, and if we can somehow find this element in the Inorder, which is here, index 2, we know that all the elements that lie on the left are going to form the right children of this 3, and whatever elements lie on the right are going to form the right side of the tree. So basically what we understand is that if 3 is the main root, which we got from accessing the last element from Postorder, then 0 to 1, this range is going to lie on the left, and 3 to 6, this range is going to lie on the right. We know that for sure. Then if we look at the range 3 to 6, if we can somehow find which is going to be the next node, the main root, which is 16, as you can see in the picture, if we can somehow find that, so if you find 16 over here in Inorder and its index is 4, which lies in this range, right, 3 to 4. So if we say that 4 has got to be, the element on index 4 has got to be the next root, then what is on the left from 4? 4 is gone already, so there's only 3 left. And on the right, we can only have elements from 5 to 6. Left is still 0 to 1. And the same thing goes on. If you look at 5 to 6, if we can somehow find from the range 5 to 6, which is the root that we're looking at, which is 12 from here, so that will be the next root. So 12 will become the next root. And the range was 5 to 6. With 5 is actually 12. So there's nothing on the left. So only 6 is left. So 6 is going to go on the right. Right? So this is something that we've understood. We know that it is easier for us to form the right tree first, and then we can move on to the left. Why is that? So if you look at all the indexes, let's clear this off. Let's create, so we do know that we do need to somehow map the elements from the Postorder to the Inorder, and we want to have the indexes, right? So for having the indexes of all the elements, because we want to know what was the index of element 3 here, so that we can decide what is going to go on the left, what is going to go on the right. So since we want to access the indexes easily, we can just create a map for Inorder, right? So 11 has the index 0, 9 has the index 1, 3 has the index 2, 15 has the index 3, 16, 4, 12, 5, and 13, 6. So if this is the map of the indexes that we're looking at, and let's try to go through the example again. So we had 3 over here. So when we start from the end for Postorder, right? So we get the first element, which is 3. We go to the map, its index is, what is the index? Its index is 2. So we do know that we've found the main element, main root, because it's the last element. So we create the main. To the right, we send the values from, since this index for 3 is 2, we send the values from 3 to 6, and to the left, we send the values from 0 to 1. Now we go to the next element, which is 16, and we're going to process the right side first, because all the left nodes are going to come at the end, since this is the Postorder. So we want to process the right first, and then we will process the left. So we will continue processing the right side. So the next node we know is going to be 16. So let's just do it like that. So the next node is going to be 16. So we just create the node 16. The range we had given to write was initially from 3 to 6, and 16 actually lies on the index 4. So now we know that to its left the range that we're going to give is just 3, and to its right the range that we're going to give is 5 and 6, right? So the next, since we're processing right first, so we go to its right now, and the range that we gave to right was 5 and 6. So we know the next node is going to be 12 just by looking at elements over here in post order. So you create 12. 12 actually has the index 5, and the range was 5 to 6. So we cannot pass anything to the left, but you can pass 6 to the right. And as I said, we're going to process the right side first. We go to right, so, and we passed it just 6. And the next node that we read from here is 13, which is going to be the element, the node for you, and 13 has the index 6, so there's nothing left in this range. So we're done over here, right? We come back, we've already traversed this range 5 to 6. Then we come back, we've already traversed this range 3 to 6, but we haven't traversed the left side yet. So we go to its left side, and there's only one element 3 over here, which has to be the next element that you read in post order, which is 15. So you make a node over here which is 15, and the only range, the only element, the range only had one number, which was 3, and 3 is actually 15. So there's no left, no right, so there's just, it's just null and null. So now we're done with the left and the right for 16, right? So we're going to go back. We process the right side of the main root, we did not process the left side yet. So let's go to the left side. Now left side had the range 0 to 1, right? So it had the range 0 to 1, and we are continuing going in the post order. So we read 9 next. It has to become a node, and when it becomes a node, it actually has the index 0. Actually has the index 1, and the range that we gave over here, passed over here, was 0 to 1. So there can be nothing on the right, right? Because 9 already has the range. It is 1. So there's nothing on the right, no elements on the right, but there's one element on the left. So you first, of course, you would make the right call, but there's nothing there. So you came back from there, you went to left. There's only one element over here, which you are going to read from post. So 11. So you create a node 11, and the range that you gave to this was just 0, and then 0 is gone. So you cannot, there's no left, there's no right. And that is how you have your tree in the end. So to recap, what we did was we just created a map for the indexes for Inorder, because we want to refer to the indexes to find out what the left part should be, what the right part should be. Then we continue traversing in the post order array from the end to the beginning. So we traverse it in the reverse order, and since we're traversing it in the reverse order, we're going to build the right side first instead of the left, and we're going to just read the values from these. They are going to be our nodes, and we're going to decide what the range is depending on whatever we've read from here. So we read 16, so we found out 4 is the index for it. The range that we had given to it was 5 to 6, so we said that 5 is going to go on the left, and 5 to 6 is going, oh, was that the range? It was actually 3 to 6. So 3 to 6, and this was 4, so we said 3 is going to go on the left, and 4 is something that was already consumed because we created the node, and 5 to 6 is going to go on the right. So that's what we did. We gave it 5 to 6 to the right. Now we can look at the code. Let's just start coding. So let's store the post order into our class itself so that we don't have to keep passing it on. We are going to need a hash map for storing the indexes. So it is going to be integer and integer, and let's just call it map. And we also need the post order index, right? Post order index, because that is how we're going to create the node, right? Whatever is the index, we're going to traverse in the reverse order. Since we're traversing in the reverse order, its value to begin with is going to be postorder dot length minus 1. The map, let's initialize it. Let's go new hash map, and let's set this dot post order to post order. Now we'll use a function recursive. We'll just call it a recursive function. Let's just call it recursive. It's going to generate the left and the right side for us. So let's just call it recursive. The function, let's call it recursive, and it is going to return the tree node, right, for us, because it'll be recursively generating the left and the right side. So we can just return whatever that function returns in the end. So recursive in bracket, and we have to pass on the starting index and the end index. Start index to begin with is going to be 0. It's going to look at the whole range, right? So starting index is going to be 0, and we've already set the post order index to the length minus 1 index, so we can just use that one. And I think we're good over here. We have to put values into the map. So for int I is equal to 0, I smaller than equal to Inorder dot length minus 1 and I plus plus. So what are we doing over here? We have to keep a map for the indexes, element and their indexes, right? So we can just put the values into map, and it's going to be in order the element and its index as the value. Now we can just create the function. So private recursive, it's going to return the tree node. So tree node recursive, and it's going to take the start index and the end index. Start index and the end index, because we're looking at the range, right? So if 3 is taken, we're going to find its index in the in order, and then the right side is going to, the start index for the right side is going to be from here. So what is that? 3 to 5, right? And for left, it's going to be just the start index and the end index are both going to be same. So what is going to be our return condition when we stop doing it? So if the start index, for the leaf nodes, the start index and the end index are going to be same. If you look at this example, 9 and 9, it's the start index and end index is going to be the same. So we want to return null when that crosses, as in the start index becomes bigger than the end index. So that's our one condition. And we also can just add a check for the post order index to not become lesser than 0, right? Because this is the last node that it can read. So in both those cases, if post order index becomes lesser than 0 or start index becomes greater than the end index, you can just return null. So for equal values, for 9, 15, 17, the start index and the end index are going to be same, and after that start index will become bigger than the end index, and we can just return null in that case. So leaf will have null as the right and the left child. Now that we're done with the return condition, we are going to want to create the root itself. So tree node, let's call it current root, is equal to new tree node in bracket. We're going to use the value from the post order, right, for it, and the index for it is going to be post order index. So we want to do the post order index. Now we want to use, for finding out the start and the end index, we want to take the in order index for this element that we read. So the in order index for that can be fetched from the map. So map dot get and the element that we use to create the node. So this. Now that we've done this, we want to decrement the post order index, because now it has to move on to the next index, and we are storing it globally. So it doesn't matter if we are on the left side of the tree or on the right side. This is basically a global value, right? That's how we want to proceed anyway. So we have decremented the post order index now, and now the current roots left is going to be, what is going to be the start index for it? It's going to be in order plus 1 comma whatever the index was in the beginning, right? And current roots right. Oh, I made a mistake. This should be right because we want to proceed with the right first. Yes, and this would have plus 1 an index, and the left side would actually have the start index, comma in order index minus 1. And when we're done with that, we can just return the current node. This looks good. Let's try to run it. Current root dot right. I'm making a spelling mistake. I have to, I like this, to call the function equal to, yeah. Okay, let's use the example, and we are good. Let's try to submit it. Okay. I hope that helped you guys. Bye.